So I'm Julia Packman, and my project was a GSP aquarium, or a geometer sketchpad aquarium. And basically what I did was I created 3 different animals on geometer sketchpad and had them as swimming in a sense. So what I did was I first created a fish, and my process was basically I created like the skeleton of the fish first on sign path. And then I went on and I connected the dots basically to create like the flesh of the fish. And then I colored it in to make a finished fish. And I also did that with a sea snake. And so I created the skeleton first and then added the flesh onto it. And then created the finished sea snake. And same with a turtle, which I actually created on a linear path because turtles don't move the way a fish or a sea snake would. Lights, please.
Yeah.
So this is the final project I created, and I have multiple different animals moving. So I created single animals first, and then I either rotated them or moved them around certain points to create more than one. So I have about 3 fish and 2 snakes and 1 turtle. And so here's my scare the grandma moment.
Everybody feel free to say gasping sounds. Whoa!
And basically everything but the turtle is on a sine function. So it creates like a squiggly line, and then the turtle's on a linear function, which creates just a straight line.
Can you show the path so they can see what you mean?
So, and then for most of them, I changed like the amount of how the sign, like the direction of the waves of the sign, and then I just moved them up and down so they wouldn't be overlapping on each other. So, and like I said earlier, I created each of the animals first like separately, and then I recreated them on the project because I wasn't sure exactly what animals would work or not, and so I also created like a dolphin and a hammerhead shark, but those didn't end up working out as well. So.
Do you want to show some failed attempts?
Yeah,
it's
sure.
always interesting.
This was the dolphin, and I originally tried to create it around a picture of a dolphin, and I tried experimenting with actually putting a picture on the skeleton itself, but that didn't work too well. But this is just the skeleton, and I created all of the points of the skeleton on perpendiculars so that they would all move together. And then this is the hammerhead shark. So combining different shapes, and then I would fill it in and make it look a little more realistic. So. Oh, and then also on my project, I had the idea of fractals, which are these things that we learned about in class, and I use them as seaweed. And basically, it's just an object or picture repeating itself on itself. So it created branches of the seaweed really well. And that allowed me to create kind of like a more realistic looking scene in the water. So.
Beautiful. Anything else you want to show? Or questions? We probably have time for questions. Anybody can ask.
So I'm forgetting the word, but like the path that you had them on.
Yeah.
So how do you create the fish going like upwards if those are the paths?
What I did was I just was able to rotate it around a point anywhere on the diagram, so it would make, in a sense, a copy of the creature, just change direction. So
Okay.
All right. Anything else? Gorgeous. Woohoo! Beautiful.
Hey, I'm Wyatt Wells.
And I'm Becca Miller, and we created created the Institute of Contemporary Art, a virtual and tangible experience, is what we titled it.
So I created a 3D model to scale, and this is the construction of it right now. If you have a time to look closer, it shows the process. So this is the outside view. I can do a little rotation. And so this is the view from the harbor. You can see the side view, and nice one, in the back. And then I created an interior as well. And currently, this is supposed to be displaying an exhibit that once was at the ICA, Shepherd Ferry, an artist. So this is an example of supply and demand exhibit. The interior, this is not exactly the way it is in the ICA, but it's based off of the way the third floor is constructed. And the reason for that was that, the main focus was the outside building. So the way I started this project was Becca and I together looked at the ICA and we kind of got a sense of it and we came up with sketches. So these are mine. These are not perfect to scale, as you can see. There's kind of a little bit differently shaped than this. So that's kind of where I started and I got a sense of it, and from there we were able to acquire a blueprint, and from there I started building. And so it's made out of foam core, which is the white stuff, and balsa wood, which is the wood looking stuff, and glue, and so that's how I made the second project.
And so after we got the blueprint, we decided to measure the side lengths and the height so that we could replicate it. And I used Google SketchUp to create my ICA. So originally, you can see the sketch that I did, and it's not to scale at all, but I was just trying to figure out how to use SketchUp. And then after we got the blueprint, I made a two-dimensional model of the ICA, and then from there I created the ICA, and I added windows and I added the stairs. And so this is the front view. So the front view and the front view, and the side view with the stairs.
Out of curiosity, how many people been to ICA? You've been to that part. So remind us, where is the ocean? Which part is the ocean?
So there's a part of the ICA that hangs over the harbor, which is this part under here.
I can maybe, this will help you. I tip it down, it's kind of ocean.
Yeah.
Right. Beautiful.
So I can show my SketchUp now. Can you turn up the lights, way? So this is my ICA, and it is put on a screenshot of the actual location.
And you use SketchUp for this, right?
Yeah, it's all SketchUp. So that's the part that looks out onto the harbor.
People are welcome to say things like, cool, whoa.
Cool, dude.
Cool.
Because it is very cool, you gotta be honest.
Yeah, we'll go inside in a minute.
Beautiful. Wow.
This is also Shepherd Ferry. It's not as it's not exact either from the ICA, but it shows that you can put stuff inside.
Beautiful. At one point, I would love to hear about collaboration, like how did each other's work influence, because this is an unusual project. You have both components together. So.
Do you want to talk about?
Yeah, sure.
Do you want to turn the lights back on? Yeah.
Okay, so I think the point in which the most collaboration occurred was towards the beginning, once we figured out where we're going to start and where we're going to go from there. So we had both these were both like her basic structure, her not to scale structure, and mine. We both used those and to get a sense of the shape and whatnot, and collaborated on that. And from there, she was able to notice some things about the buildings that I weren't from the way she was doing it, such as these, I don't know what you want to call them, these like little window frame fillers type thing. And I was able to notice some other things, some shapes and angles, such as like this little hang down thing was a little bit easier doing it like hands-on and whatnot. So in that sense, we were able to kind of, if one of us couldn't figure something out, the other one was sure to probably have the answer because we're doing such opposite experiences. So
Because of the materials that we use two very, very different materials. So, like Wyatt was saying, I had a very, very difficult time creating this hang down thing. And it was easier for Wyatt to create it because he could just use his hands, and I couldn't really use my hands because I can't feel it. So that was one point when I was able to go to Wyatt and ask him how he did it, and we definitely worked off of each other. So.
Did you know SketchUp at all before this project, or this
not
was
at
just
all.
from
This
scratch?
was the first sketch that I did, which is the not to scale sketch. I used that to teach myself how to use SketchUp and how to tackle the project.
Beautiful. Questions? Anybody? Ready for Chris Rowe's architecture class?
Yeah.
signed up for it.
Alrighty. Beautiful, beautiful guys. Very well done. Okay?
So I'm Fortune Jackson Bartelmas, and the title of my project is My Fake Solar System. My presentation is divided into 5 parts, 2 parts being the Mysterium Cosmographicum from Johannes Kepler, he's a mathematician, and elliptical orbits, parabolas and vantage point, which is like the motion and like tracing what like the motions
Yeah.
of the things that are going on. And then the last part will be my finished product in Cabri 3D V2.
Okay, beautiful. When we see these will make more sense. Are we ready for
Yep.
lights off? Yeah, please.
So here's the Mysterium Cosmographicum. It's,
If you click on somewhere, we can see it better.
yeah, maybe I can zoom in. Yeah, that's good. So the white part is the dodecahedron. The blue is the cube, sorry. The green is the tetrahedron, the yellow is the octahedron, and the purple is the icosahedron. So this was supposed to represent the solar system, and the dodecahedron being the white would represent the universe. And inside of each platonic solid, there would be a sphere that would determine the inside of each platonic solid there would be a sphere nested, which would determine the rotations or revolutions of each planet. And next is like the basic part of my solar system. Here's Earth, here's the moon, here's that's the sun, here's Mercury, but it's so small I can't click on it, here's Venus, and here's Mars. So they don't all move in circular orbits, they actually move in elliptical orbits. So just to show that, I'm going to trace Earth and start the animation. So you can see the moon revolving around Earth, then these guys moving in elliptical orbits, and I'll turn this around for you. You can see it's not a perfect circle. So then here, the left part shows the parabolic movement of the comets in my last part of my presentation, and then the right part shows the vantage point of a moon. So that's what it's like when you're sitting on a moon and looking at the sun. So when you animate here, this shows the parabolic movement of the comet with the sun as a focus. And just to show what's actually going on,
Another scare the grandma moment.
so then we move over here, and instead of your usual diagram with the sun in the middle and then everything revolving around that, you have the moon in the middle and the sun and planet revolving around that. So picture yourself on the moon and looking at the sun, and this is what it looks like. It moves in a very weird way. It never overlaps itself. And just to show what's going on. And the last part of my presentation. So this is my fake solar system. You have all these planets moving around. They actually have the same amount of moons as in real life. So here's Jupiter here. I think it has 18, and Saturn has 16, and Uranus has 15. Uranus actually has a ring. Here's Saturn's rings right there. Here's my parabolic comets moving around. If I trace them, you can, let me stop it. So if I trace them, you can see they move in a parabolic motion. One of them is really weird, so maybe this is the weird one. Nope, it's a good one. So it's moving in a parabolic motion. See this in 3D.
Can you give the world a spin so the whole thing starts spinning, and while you're animating, of course. Can anybody tell what is fake about this system? I mean, obviously there's some measurement issues, etc. maybe, but what is one thing you notice that might be not shared by the actual solar system? Anybody can? Me?
The speed of
Speeds, those are very legitimate difficulties, but there's one choice he made which looks fabulous, but
Yep.
the solar system doesn't have it. Anybody knows? Yeah?
The color of the moon?
Colors, true. Anything else?
I'm just showing how Jupiter moves in an elliptical orbit, actually. It's a pretty close to
Anybody else?
it.
Fortune, tell us. What is
They're not, the moons aren't on the same plane. As you can see, when you turn it this way, they're all like lined up, but in real life they'd probably be on different planes and rotated so that they're not all orderly like that. And
would
also
it- yeah?
the asteroid belt probably wouldn't be a circle, but in every 3D you can't have more than one thing moving on an elliptical orbit.
And
So-
the moons wouldn't be all on the same circle, right? They'll be on
Yeah.
different circles. Concentric, but different circles.
So, scare the grandma moment.
Here we go.
And delete
The
this.
one you've been waiting for.
I gotta zoom out for this. Alright. Are you ready?
Yes, we are. Let us enjoy this moment for a second. Great. Okay, any questions, anything else? Alrighty, beautiful. Beautiful done.
Hello, I'm Nate Cassidy, and my project is aerodynamics of cars. I studied the basic geometry of a car, and some of the key aspects I decided to do were the bow of the car, first the shape of the car when you're looking from the front, the shape of the car when you're looking from the side, the spoiler / wing of the car, and the downforce and drag of the car. As you can see on this, there's a lot. There's wind tunnel testing, which is a way to test aerodynamics of a car. Here's a picture of bad aerodynamics. You notice that there is this weird, fluff or cloud of air that is not really moving, and that is an example of bad aerodynamics. But there's two pictures of good aerodynamics where the white line, which is some sort of cloud, or I guess in a wind tunnel, is thrown out, and there it is a straight line and is not broken up, is not spoiled. And that is where the term spoiler comes from, because on the car, the spoiler is at the end of the car, and it keeps the air moving so it doesn't spoil the air. The bow of the car is used to, one, help reduce drag, which makes the car faster, but two, increase downforce of the car, which improves the braking efficiency and cornering of the car. The closer it is to the ground, the more, the less drag and more downforce you have. And if there is a lack of downforce, then you get a flip of a car, which happens right here. It's famous in a famous race. This car flipped over completely because the air got underneath the car and it just lifted up. And that is it.
Okay.
As I said before, a way to test the aerodynamics of a car is put into a wind tunnel. So I simulated a wind tunnel with a geometry sketch pad, and the dots represent air particles.
Whoa.
And so you see the air particles follow the lines of the air, how it would be affected by the car. And when I was testing the car, when I was testing the aerodynamics of the car, I decided to build my own car to have the best aerodynamics possible of it. And so you notice that when you look from the side, that the bow of the car is very close to the ground, so air cannot get underneath it. There are many curved lines of the car. There's not a lot of straight edges of the car. Straight edges reduce, increase drag, and that slows down a car. And there's a spoiler at the end, which I was saying before. And then looking from the front, you notice that there is a lot of the car is located closer to the ground, and very little is located above it. That increases the center of gravity of the car, so the car will not flip over in a turn. And it also reduces drag. And that's it. And how I built this was I got car blueprints, and the car blueprints were a side view, a top view, and a front view of the car. And so I just traced it out, and then I individually cut each segment that I didn't need, and then I rounded out the edges, and that's what I came up with.
What brand car? Is this Mercedes?
This is a Mercedes race car, which it doesn't have a type.
Good. Click on some inside.
Alright, and so, as Salim said, I should do this ad that was on TV about a car doing a flip. And so I replicated that. And it took off from a ramp, which is very important. And that's it.
I'm Ben Stoloff, and I did the geometry of wind turbines and windmills. So I started off by creating some gears, just to familiarize myself with GSP, Cabri, and also just get a general sense of wind turbines. So this was my first thing I created in the project. It's just really simple gears that just rotate. I moved on to this in Cabri, which it's in 3D obviously, and it's more detailed. And then so I finished with the interior of a wind turbine. So basically, the rotor blades of a wind turbine are rotated by the wind, and then they turn this thing, which is called the low-speed shaft, which turns the gears, and then it turns the high-speed shaft, which is faster, which then in turn turns the gearbox, which generates electricity. So that's how it works. Then I moved to creating the outside of a wind turbine and a windmill, which is shown here.
Okay.
So this is gears. So something there.
So which part of the wind turbine would that be? Is that inside
Yeah,
of
this
it?
is the interior. This would be in the gearbox. So I can show you on here. Well, if these would be contained in the gearbox, and so this point which is the low speed shaft and how the energy for the electricity generation is created would be connected to there. So when the blades are rotated, it rotates that. And then just show it.
Ooh.
So then I also created a windmill just to see how wind technology has changed, and I came up with this. So basically, it's actually pretty similar to the wind turbine. However, windmills would just be used for like grinding grain or water occasionally. So like, not as complicated things, but how the word is pretty similar.
That's the Don Quixote version.
Yeah. So this is how. So I'm finished with a wind turbine. So this was definitely it was hard to construct everything so it all fit together. But, man,
Hey, any questions? Anything? Alrighty. Woohoo.
Maybe? No, wait, I don't. Oh. Okay, so I'm Emily Marcoux, and I decided to try to make chairs out of newspaper and duct tape, and I never want to look at duct tape again. But so the original goal was for it to hold a cat, and it far exceeded that. These are my two prototypes. This one is much smaller than this one because I found out how much material it took up and how much time. And so I was like, hey, let's make this one a little bit smaller when I tried out this design. So I noticed in like just some observations of like structures and stuff that they had this shape, and I wondered how that would work in a chair as far as like weight distribution goes. And it ended up working pretty well, like the more triangles I put in for support. So this I'm not going to step on, but I actually am able to stand on this one without it.
We could have some drummers. Here we go. My goodness.
And this
The
is
proof of the pudding is the eating. Here we go.
So my poster real quick just shows what it kind of looked like in the process. That's all of the materials I used to make this one. And yeah, so this is my final chair, which I'm not going to stand on because it's a much farther fall, and also the legs are much taller, so it makes it like more weak. So, but I can sit on it, and my feet don't even
My
touch the
goodness.
ground, so it's a good thing.
Let me get that. One more time. One more time.
Okay.
Drummers. Alrighty.
So I actually ended up, since rolling it by hand took so much time, I ended up making a little kind of creation. I took a drill and a thin steel, like metal rod thing, and I attached it to the drill and I taped it lightly, and then I like pushed the drill and it slowly like rolled it up, which still took a lot of time, but easier on the hand. So, and I made two-ish, three-ish things
Okay.
on
Beautiful.
whatever this was called.
Google SketchUp.
Yeah, Google SketchUp. Okay, so I don't remember which one was which. Okay, so this is, I just kind of like experimented with like different shapes of chairs that I could not do using duct tape and newspaper, obviously. So yeah, that's just one little design. And this is another one, but I kind of went for a more like stone-ish look for this. The electronic part wasn't really a big part of my project. But and then this one was totally spontaneous and kind of like random. I tried to make it appear like there'd be like little, for whatever reason, water in a chair. This is my circular chair, which I also tried to make it look like stone.
Yeah.
Okay, so just going back to the previous one, kind of tried to make it more of like an hourglass-ish shape, for no particular reason, but.
Wyatt has a question, I think.
So like, with these chairs and whatnot, why do you think they wouldn't work with duct tape and whatnot? Is it just like the dynamics of it? Or?
Yeah, I would have no idea how to shape it. I mean, I'm sure you could do
Mhm.
it, but I just don't know. And plus, like with this, you would need some kind of support because it really, just having the straight legs like that, it would just fall over.
Okay.
So.
Beautiful. Any other questions? Anything?
And then this was done. So, yeah.
Alrighty, beautiful.
Alright, so I'm Alexander Porgu, and I did my project on the geometry of Solowit's sculptures. Solowit was an artist. He was born in Connecticut, but stayed mostly around New York, and he was the founder of conceptual art, and from that came minimalism. And conceptual art, it's pretty much taking, it's not the Mona Lisa, which anyone can do, but because the original is so valuable, it's just, that's the idea. Maybe what he does is he takes blocks and makes shapes with them, and he does the instructions, and you buy the instructions and you build it wherever you want to. So it's, he sells the idea and then you take it down and you can rebuild it somewhere else, and the piece itself without the license is kind of useless, but the idea is what he sold. And I looked specifically at his sculptures because I started off with, I was going to look at the artwork in the De Cordova Sculpture Park in Lincoln, and I saw this a piece called The Tower there, and I'd seen previous solo work, and I was really intrigued by it. So, and my mom used to work at the Concord Museum, so I asked her about it, and she said, yeah, and I can try and set up an interview with the curator of the museum. So I did that, and I have, here's a preview of. Hello, I'm Alexander Porto. I'm here with Nick Knudsen, the curator of the Concord Museum. I'm going to ask him a few questions for my geometry project on solid. So, Mr. Then I put the rest of the interviews on YouTube. It's 9 minutes long. It's talking about Solowit, Solowit's work, then how the park acquired the piece, and then kind of Solowit's relation to geometry, because I was really intrigued because his work looks geometric, and I was trying to figure out how, and I applied to the tower, I applied a formula from Gauss, which I used it to find the volume, and what it was, it's pretty, because the tower, the piece, it starts at 0, and it's pretty much a spiral, starting from 0 and going up and around itself. And if you use the formula right here, it's for adding consecutive numbers, so if you use the formula you can find the number of blocks in it very quickly. So this sculpture has 300 blocks, and we couldn't really find any significance in the number we were looking for it. But then the other significant thing is that it happens 24 times, so it might represent hours of the day, something like that. And then I worked on other parts. I first went to other sculptures that he did, then I tried to make my own, and then I tried to do inverses of different sculptures. So this is another piece of his pyramid. I put everything, I tried to make my own sculpture park. It's on the path. So there's the tower. And this one right there, that's the inverse of it. So if you put them together, you would get that one, and it makes an almost complete rectangle. And then I put the inverse and then the upside down version of the inverse, and I kind of made a cannoli thing. Which you can go through, it's hollow. And then I made another version of the tower out of columns instead of squares. So, see it's circles. And this is his work. And then I made this sculpture. I mean, part of his work is, it's all, it's symmetrical. So I tried to keep that, but then by using Google SketchUp, because he didn't have the program when he was making it, so I tried to make something that he couldn't make in real life, because physically this wouldn't stand up, it would collapse on itself. So I tried to experiment with that, and that is my project. So if you have any questions, ask me.
Beautiful. Woohoo. Alrighty.
Okay, I'm Isaac Watts, and I did my project on the geometry of rock climbing. I've been rock climbing for 10 years, and it's something that's a big part of my life. And specifically, the way I started was by recreating this gym that I actually competed on 2 years ago, and I'm in the national and the world rock climbing competition circuit, so I realized that there are a lot of geometric aspects of the gyms that I climb on. Okay, so I've had routes that I competed on this wall, going up that. up this space and up here. This is a view of the whole thing. That's scale.
It is to scale. I'm gonna ask you. It's a person looks that small.
Yeah,
in
a
the-
person is that small in comparison. It's about 80 feet tall. I've had roofs up that. And, yeah, and so in addition to creating this gym, I also tried to simulate climbing falls in Cabri 3D.
How do you do that?
So the way I started was with this one. So this is the first one I did. See it? It's graph. So it's along a circular. It's graph along a circular arc. So the motion is in a circle. And that's a bit cartoonish and unrealistic, and also the arms are flailing in a bit of a goofy way. So I then tried to see what would happen if I graphed it along a parabolic track, and so that's the second one. Also a little bit goofy. But then I tried to make something more simple but with a more realistic motion, and this is what I ended up with. So the person starts up there and falls, and it's sort of like a bungee motion, because realistically the person is caught on the rope sort of gradually and then comes to a halt. It's not as much of a bounce. Abrupt halt. And then my final thing that I ended up with was, this is the Blair, the person who holds the rope for the person who's falling, who gets sucked into the rope and moves up as the person falls. So I used parabolas and then to get the bungee motion, and then the inverse. So the person goes up when the other falls. And yeah, that's my problem.
Alrighty, any questions?
Hi, my name is Emerson Davis, and my project is on the geometry of swimming. I started swimming when I was about 2 years old in just a pool in Newton. And the ocean has always been a fascination of mine. I am a certified NAUI advanced scuba diver, and yeah, I usually scuba snorkel Florida Keys. It's great, and I see a lot of animals when I'm down there. Tubing, I've seen sea turtles, I've seen a lot of fish. And looking at them and the way people swim, I decided there's probably some geometry in that. So I decided to take a look. All right, some stuff up. This is a cycloid. Well, mainly this point up here. It forms curves behind it as it goes. I think early in the year, Slim talked about a square bike having wheels, and that's how it would progress. Well, looking at this, I really thought that there was something in this, not in the point, the normal cycloid point that goes around, but in this point right here, where the line intersects with this line the circle is traveling along. It's got kind of a back and forth motion, and a lot of swimming is like that. So I decided to utilize that. Now, the first animal that I created was a human. Yeah. And a cycloid was used in the production of it. I decided to recreate the breaststroke, as number one, it's my favorite swimming stroke, and number two, it's pretty simple to replicate. So, person swims like that, and when done in sync, swims very easily, and leaves behind some pretty cool patterns as he progresses. I'm gonna scare the grandma, I think. There we are. So yeah, you can see the cycloid on the swimmer. Next, well, in relation to this, the turtle created also used a cycloid.
Whoa.
Also leaving behind some pretty cool patterns. So yeah, it's a turtle. I'm gonna scare the grandma. It was based off of this up here, where I created the circle, and used kind of similar techniques to person to create the limbs, rotating this one down here, create kind of motion. It's an opposite motion, as he's not really reaching forward, but instead pushing the water behind him. So yeah. The third animal I created was the fish, and this was created in kind of a different way. I tried initially trying to incorporate a cycloid into him, but then kind of figured out that didn't really work. So instead, I used circles, moving along a waving line. This line was created using a sine function, which is on my poster over there, incidentally, the exact one. And yeah, the fish kind of swims a little like this. So the water is trailing behind him, and he's moving kind of a snake-like motion. Fish undulate as they swim, and it's pretty awesome. And here they all are together, swimming along. And of course, the obligatory scare the grandma button. All them moving in tandem.
Turtle one.
Turtle one. I think, yeah, ironic, turtles winning the race.
Who's fastest?
So yeah, that's my project.
Hey, my name is Martha Hoffman, and I did my project on the fold and one-cut theorem. So basically, this theorem states that if you draw any polygon on a piece of foldable material, you can fold the material in such a way that with one complete straight cut, you can cut out the shape. And so it's really hard to understand. So I'm just going to do a demonstration. So I'm trying to cut out these dark black lines, the thick ones. So I fold up the paper.
This was
and I
whose
cut-
trick, by the way? Remind us. Historically, this is?
Oh, I was going to get there.
Okay.
Okay, so I'm going to just cut on this one black line. And what I should get is holes right there. So it's kind of like a magic trick. And so what I did to learn how I folded this, I used Geometer's Sketchpad. Yeah, okay, so I just focused on quads and triangles. So basically you take any random quad, so this is called the straight skeleton technique. You basically find the straight skeleton of the shape and then you fold on the lines. So you find the angle bisectors of the quad, and then on the lines you place a random point and then make this line, so you make the outer lines parallel. So you basically make a miniature polygon inside. So you can move it up and down these lines. And so once these two meet in the center, these 2 points, you place a dot, and then you keep doing it. So those two meet those guys, and then you place another dot, and so that you can connect them. So now you've just traced the angle bisectors and the distance between the two points. And then from each vertex in each region of the straight skeleton that you make, you shoot perpendiculars. And so to fold this shape and to cut it out, you basically valley fold, so like go like that with the paper on the perpendicular. after I folded it up. So, just a bit of history. This was first used by the Japanese, we think, we're pretty sure. And they would hold contests to see how smart someone was at math. I'm not sure how to pronounce it, like Wakukushir or something. I'm not sure. And then it was also used by Betsy Ross for the American flag. She would cut out the stars using this technique. And Houdini also used this as part of his magic tricks. Right there. And the most recent accomplishments with this theorem was by Eric Demain and a few others. He basically proved that this theorem works, and it's a really insanely complicated proof, so I'm not going to talk about it now. But so he's a really important figure in this theorem, so you should watch out for him. And so I was inspired by this theorem because it's really cool. It's like a magic trick. And so I used the theorem to cut out shapes, just to make a little quilt. And I also taught a class to some little people, like 10-year-olds, basically like how to use this trick, use the theorem as a magic trick. And it worked pretty well. So yeah, that was my project.
Yeah.